Today we're going to be learning about piecewise functions. And so I have an example here of a piecewise function. And one thing you might be asked to do is to work out these individual function values, or you could be asked to graph the piecewise function. So let's look at these first. Well, the number inside is your x value. So if x is -5, which one of these conditions is it in? Well, -5 is a number less than -4, so we use this formula. So f evaluated at -5 is -5. What about this? We need to find the condition where -4 is included. As we can see from the symbol here, -4 is not included. From the symbol here, -4 is not included in there, and it's not included in any of them. So -4 is not in the domain, so f evaluated at -4 is not defined. Or it could be D and E for does not exist, depending on what your instructor wants you to use. What if x is -3? Well, if x is -3, we can see it lives in there, so this is the formula we use. So f evaluated at -3, I'm going to replace the x value with -3. Make sure you do it inside parentheses. And so that's going to be equal to +9, so I get 9 minus 9, and I get 0. What about f evaluated at 1? Well, 1 does live in here because of the symbol. So I will use this formula again, and so wherever there's an x, I'm replacing it with the number 1. So I'll have 9 minus 1, and I'll get 8. What about f evaluated at 2? Not here, but it's right there. If x is equal to 2, then f of x is equal to 4. So f of 2 is equal to 4. What about f evaluated at 3? Well, 3 doesn't live in any of these. So once again, this does not exist or is not defined. What about f evaluated at 4? Well, if x equals 4, because of the symbol here, it's included. So I will use this formula. So f evaluated at 4 is equal to 2. What about f evaluated at 9? Well, if it's 9, it lives in there. And so this will be the square root of 9, which is equal to 3. Okay, now let's graph this function f of x. Now, what I'll see a lot of students do is they'll get their graphing calculator out, and they'll put each of these in, and then press zoom 6, and we get that. And then they'll draw that picture. Or if it's a multiple choice question, they'll circle this graph, in which case you've just thrown away your points. What you see there is not a function. It doesn't pass the vertical line test. What the student has forgotten to do is to apply these restrictions. So if it were that easy, okay, then we wouldn't even bother to teach you about piecewise functions if all you had to do was graph all of them. We've got to include the restrictions. So what do we mean by that? Well, let's look at each of these separately. Here I've drawn the graph of f of x equals x. That's without any restrictions, but for this piecewise function, the restriction is x is strictly less than -4. So I'm going to actually draw the restriction in now. So I want the graph of this, but only when x is less than -4. So I want all the points whose x values are less than -4 up to but not including. So this is the piece that I want. That's the piece that I want for the first one. What's the restriction on the second one? X is between -4 and +1. We're not allowed to include -4. So I'm going to start here at this point, but it is not included. And I want everything until I get up to x equals +1, and because of the symbol there, that is included. So I'm going to fill that dot in. So that's my first piece, that's my second piece. What about the third formula? We have f of x equals 4. And so the graph of f of x equals 4, y equals 4 is a horizontal line. But now what's the restriction? I only want it when x is equal to 2. So when x is equal to 2, I just get a point and nothing else. So that's my third piece. And finally, what about my fourth piece? I want the graph of this, the square root of x, but only when x is greater than or equal to 4. So I come here at 4, and I am going to include this point because of the symbol. I start here, and I want everything to the right of it. So what we have to do for a piecewise function, that's why it's called the piecewise function, we take each of these pieces and we put them into one graph. And that is the graph of my piecewise function. And everything that I calculated here in the beginning should be consistent with what we find in the graph. All right, so if I'm just looking at the graph, what is f evaluated at -5? Well, I come here where the x coordinate is -5 and the y coordinate is f of -5. And what is f of -4? Well, I look for the point whose x coordinate is -4, and there's not one. So this does not exist. What about f evaluated at -3? I come here at x equals -3, and the y coordinate of that point is 0. So f of -3 is equal to 0. What about f evaluated at 1? Here's x equals 1. The y coordinate of that point is f of 1. So f of 1 is equal to 8. What about f evaluated at 2? Here's x equals 2. The y coordinate is f of 2. So the f of 2 is equal to 4. What about f of 3? Well, there is no point with x coordinate 3. So that does not exist. 3 is not in the domain. What is f of 4? I can see here if x is 4, the y coordinate is 2, so f of 4 is 2. And what is f of 9? Well, if x is 9, the y coordinate is 3, so f of 9 is equal to 3. Okay, what is the domain if we were asked for the domain? Well, we use the x coordinate. We use the x-axis, to describe how wide this thing is. Going from left to right, I'm coming in from -infinity up to, but not including -4. There is a gap at -4. If you look up or down, there's no point. So we got to jump over that gap, and then I pick it up again, and I continue until I get to 1, and 1 is included. And then there's a gap, and I don't have anything until I get to 2, and I just have that singleton 2. So sometimes it's written with square brackets, other times curly brackets. Then there's another gap, and I pick it up at 4. 4 is included, and then it goes on forever. What would the range be? Well, the range would be that. Now, how do you get the range? You use the y-axis to measure how tall, going from bottom to top. Well, there is no bottom, so we're coming in at -infinity. Now, how do you know if you have a gap? You have a gap if you look both left and right and there's no point. So when I come up here to -7, there's no gap at -7 because I do have a point at -7, a y coordinate -7 right here. So there's no gap. There's no gap. I have points there. Again, if I look left, I always have a point. I always have a point. Now you might think, oh, well, you stop at 9. No, you don't. Because this is slowly but surely getting higher forever and ever and ever. And if I could take this out far enough, eventually it's going to overcome this height here. All right, so that one can be tricky. But that was the range for that one. Okay, so that looks like we've gone through everything. So just don't hesitate to email if you have any questions.